Hi friend, you're welcome again to Mwalimu Theophil Academy. In this session, I'm going to teach on the preferential discharge of ions during electrolysis. When I say preferential discharge of ions during electrolysis, I mean during electrolysis, more than one kind of ions of the same charge migrate to each of the electrodes. There must be a factor which determines which of these ions is to be discharged. So this is the role which I have today. Today, I'm going to make you to know these factors which determine the kind of ion to be discharged at a particular electrode. Let us start. The first factor to determine the ion to be discharged is the position of an ion in an electrochemical series. I mean, is discharge of an ion. The second factor is the concentration of ions. And a third factor is the nature of electrode. Now, each of these three factors is going to be explained in details. Let us start with the position of an ion in an electrochemical series. First of all, when I say an electrochemical series, I mean the arrangement of ions depending on the ease of discharge. This is what we call an electrochemical series. As you see, it has the metal ions, as you see them here. It has also non-metallic ions, as you see them here. Here it is written readily discharged. It means that at the upper part, the ions which are found at the upper part are not easily discharged. As you move downward, the chance for the ion to be discharged increases. And at the end, it is written most readily discharged. It means that as you move from upward downward, the chance for an ion to be discharged increases. Now, let us see, for example, if the electrolyte you have is copper 2 sulfate. Now, take a look if we have an electrolyte copper 2 sulfate. Copper 2 sulfate. Now, what ions will be present in this kind of solution? Now, assume this is an electrolytic cell, and within this electrolyte is made up of copper 2 sulfate. Now, if this electrolyte is made up of copper 2 sulfate, which possible ions do we have in this solution? The possible ions will be, let us first see the dissociation of copper 2 sulfate. Copper 2 sulfate will dissociate to form copper 2 ions, and sulfate ion. As you may see it here, as you may see it here. Also, apart from copper 2 sulfate, you have to know that as it is the solution, to mean that there is water within. So let us see also the dissociation of water. The dissociation of water will lead to the formation of hydrogen proton, and hydroxyl ion, as you may see. So it means that in this solution, if copper 2 sulfate is an electrolyte you have dissolved in water, it means that we have four kinds of ions. These are copper 2 ions, sulfate ions, hydrogen proton, and hydroxyl ion. Now, let us see the reactions at each electrode. I mean the reaction at cathode and anode. Let us start with the reaction at cathode. You have to know that the positive ions will migrate towards the cathode to be discharged. Now, the positive ions which will migrate towards the cathode, we have copper 2 ions and hydrogen ion. Now, which one of the two, copper 2 ions or hydrogen proton, will be discharged? We have copper 2 ion and hydrogen proton, the positive ions, I mean cations, to migrate towards the cathode for being discharged. Now, which one of the two will be discharged? Yes, here, simply, we are going to look across the electrochemical series. In electrochemical series, we find that copper 2 ions is below hydrogen proton. So it means that as copper 2 ions is below hydrogen proton, copper 2 ions is going to be discharged in preference to hydrogen. So the reaction at cathode will involve the discharge of copper 2 ions to form copper 2 ions to form copper metal as you may see. So this will be the reaction at cathode. Let us also see the reaction at anode. Reaction at anode. Reaction at anode. The reaction at anode. You have to know that the reaction at anode will involve the migration of the anions. I mean the negative charged ions. Now, which negative charged ions do we have? We have two negative charged ions. We have sulfate and hydroxyl ion. We have sulfate ions and hydroxyl ions. Now, which one of the two will be discharged? Let us see the arrangement in electrochemical series. In electrochemical series, we find that hydroxyl ion is below the sulfate ion. So here, hydroxyl ion is going to be discharged in preference to sulfate ion. Now, the reaction at anode will involve the discharge of hydroxyl ion to form water and liberate oxygen gas. And liberate oxygen gas. Water to form water and oxygen gas, as you may see. So this will be the reaction at anode. Now I think you have understood well on the first example, but it is not enough. Let me add the second example. A second example, I am going to explain on the electrolysis of dilute sodium chloride. Electrolysis of dilute sodium chloride. Now let us see the way we carry out the electrolysis of dilute sodium chloride by basing on the first factor of easy discharge of ions. I mean by considering the position of one ion in electrochemical series. Now, if our electrolyte now is sodium chloride, it means that sodium chloride is dissolved in water, as you may see. If in this solution there is sodium chloride, what possible ions will be present? The prevailing ions will be the ions according to sodium chloride. The ions according to sodium chloride is in dissociation, it will dissociate to form sodium ion and chloride ion, as you may see, sodium ion and chloride ion. So here it is not only that the ions present are due to sodium chloride. You also have to know that sodium chloride is dissolved in water, so there are ions according to dissociation of water. Now let us see the dissociation of water. The dissociation of water will give us the hydrogen proton and the hydroxyl ion. Now we have these four kinds of ions. We have hydroxyl ions and the hydrogen proton from water. Also we have chloride ion and sodium ion from sodium chloride salt. So here now let us see the reaction at cathode. Reaction at cathode. The reaction at cathode will involve the migration of positive ions, I mean cations. Now, the cations which we have sodium ion and hydrogen proton. Sodium ion and hydrogen proton. Now, it means that the sodium ion and the hydrogen proton will migrate towards the cathode. Now, which one of the two will be discharged? Let us see their position in electrochemical series. Their position in electrochemical series, as you see, hydrogen proton is below sodium. As sodium it is here, but hydrogen proton is here. So it is simply that hydrogen proton is below sodium. Now, hydrogen proton will be discharged in preference to sodium. So the reaction at cathode will involve the discharge of hydrogen proton. The hydrogen proton will be discharged to liberate hydrogen gas. As you may see. You're going to get hydrogen gas. Now, this is the reaction at cathode. Let us see the reaction at anode. Reaction at anode. The reaction at anode will involve the migration of negatively charged ions. I mean the negative charged ions, I mean the anions. Now, which anions do we have? The anions which we have two kinds of anions, chloride ion and hydroxyl ion. Now, which one of the two will be discharged? We have to look on the arrangement in electrochemical series. The arrangement is that when we look at them well, hydroxyl ion is below chloride ion. So hydroxyl ion is going to be discharged in preference to chloride ion. Now, the reaction at anode will involve the discharge of hydroxyl ion to give water and liberate oxygen gas. Now, hydroxyl ion is going to be discharged. Hydroxyl ion is going to be discharged to give us water, oxygen gas, and water and oxygen gas, as you may see. Now, this is the way we use the factor of the position of the ions in electrochemical series to determine the specific ion to be discharged. I hope you have understood. Now, after this first factor, let us shift to the second factor, which is the concentration of ions. The second factor which determines the preferential discharge of ions during electrolysis is the concentration of the ions. Now, the concentration of ions is another factor in such a way that the electrolysis will involve only those ions which are highly concentrated, while those ions which are available in small amount are ignored. Now, let us see the electrolysis of concentrated sodium chloride. Now, if the solution is made up of sodium chloride and it is highly concentrated, it means that the electrolysis which will take place, it will involve the discharge of sodium and chloride ion, regardless other ions from water, I mean hydroxyl ion and hydrogen proton. Now let us see the dissociation of sodium chloride. Sodium chloride will dissociate to form sodium ion and chloride ion, while also water will dissociate to form hydrogen ion, I mean hydrogen proton, and chloride ion and hydroxyl ion, as you may see. Now, in this solution, it means that we will be having four kinds of ions where the ions are sodium ions, chloride ions, hydrogen proton, and the hydroxyl ion. But let us see the reaction at cathode and anode. Reaction at cathode and anode. Let us start with the cathode. Reaction at cathode. We know that the positive ions, I mean cations, migrate towards the cathode. Now, the cations to migrate towards the cathode here are sodium ion and hydrogen proton. Now, the sodium ion and the hydrogen ion will migrate towards the cathode. Now, which one of the two will be discharged? You have to know that when you are considering the one to be discharged, it will depend. Here, the factor of the position of ion in electrochemical series will not be considered. Why? Because the factor of concentration will outweigh it. So here we are going to consider the factor of concentration and not again the factor of position of ions in electrochemical series. So when we consider the factor of concentration here, at cathode, sodium ion is going to be discharged. Why sodium will be preferred to hydrogen, though hydrogen is below in electrochemical series if you compare to sodium? The reason is that sodium is highly concentrated, so sodium is available in abundance. Now, sodium ion will be discharged at the cathode due to the factor of concentration, as it is highly concentrated if you compare to hydrogen proton. Now, at the cathode, sodium ion will be discharged. Sodium ion will be discharged to sodium metal, as you may see. Now let us see the reaction at anode. Reaction at anode. Reaction at anode. The reaction at anode will involve the migration of negative ions, I mean anions. Now anions which we have chloride ion and hydroxyl ion. At the same time, here the factor of position of an ion in electrochemical series is going to be ignored because we are referring to the factor of concentration. So the ions which are highly concentrated here are going to be discharged. So the preference will be given to the ions which are available in abundance. Now, as sodium chloride is highly concentrated, so chloride are available in abundance. Now, chloride ions are going to be discharged in preference to hydroxyl, though hydroxyl ion is below in electrochemical series than chloride. So we expected that if the factor of electrochemical series would be taken into consideration, hydroxyl ion would be discharged, and the chloride ion would be left in the solution. But the reverse is correct. Now, chloride ion is going to be discharged now chloride ion is going to be preferred. Now chloride ion is going to be discharged and the hydroxyl ion is going to be left in the solution due to the fact that chloride ion is highly concentrated than hydroxyl ion. Now, the reaction at anode will involve the discharge of chloride ion. Chloride ion is going to be discharged to form chlorine gas. As you may see. So this is the way we do. So here, this is the reaction at anode, this is the reaction at cathode. Provided that the electrolyte which we are given, sodium chloride, is highly concentrated. So the electrolysis will involve only the ions from an electrolyte which is highly concentrated and ignoring that electrolyte which is less concentrated. This is the way the factor of concentration determine the preferential discharge of ions during electrolysis. Let us see a third factor. A third factor which determines the preferential discharge of ions during electrolysis is the nature of electrodes. You have to know that the nature of electrodes, you have to know that different electrodes are made up of different materials. Now, the material making an electrode can decide what kind of ions to be discharged. This implies that when you bring a same electrolyte in different electrodes, you can find that the products which can be obtained can be different, as the ions to be allowed by each electrode is different from each other. Now, let us see when we use mercury electrodes to electrolyze the solution of sodium chloride. Mercury electrodes, especially when we use mercury, especially the reaction at mercury cathode. Now let us see the reaction at mercury cathode when our electrolyte is sodium chloride. Now we have to know that if it is a solution, it means that the prevailing ions will be the sodium chloride will dissociate to form sodium ion and chloride ion as usual. Also, the water, you have to know, as it is dissolved in water, the water will dissociate also to form hydrogen proton and hydroxyl ion. So here we are going to see the reactions at cathode. Reaction at mercury cathode. At mercury cathode, as I have told you that the cathode here, the cathode and electrodes used are made up of mercury material. Now, the reaction at mercury cathode, what ion will be discharged here? The ions to migrate to the mercury cathode, as it is cathode, are the positive ions. I mean sodium ion and the hydrogen proton. Now, which one of the two will be discharged? Now, you have to note that the nature of electrode here is going to be applied. When the electrodes are made up of mercury, the reaction the reaction at cathode will involve the discharge of sodium ion to form sodium amalgam. Now, it means that the reaction at cathode will involve the discharge of sodium ion, to form sodium ion, to form sodium metal, This sodium metal is going to combine with the mercury to make sodium amalgam. We have seen the electrolysis of sodium chloride when the mercury cathode is used. Now, what if the platinum electrodes are used? Platinum electrodes are used to electrolyze the solution of sodium chloride. How will the reaction occur? Let us see the reaction at platinum cathode. Let us see the reaction at platinum. Let us see the reaction at platinum cathode. Platinum cathode, as we saw on mercury cathode. The reaction at platinum cathode, as usual, at cathode, the ions to migrate are the cations. Now the cations which we are going to have, we should have the dissociation of sodium chloride to form sodium ion and chloride ion. Also the dissociation from water, to form hydrogen proton and hydroxyl ion. So here the ions to migrate to the platinum cathode are the positive ions cations. I mean hydrogen proton and sodium proton. But here the nature of electrode is going to decide which ion is going to be discharged among the two, regardless the easy discharge of ions. I mean, regardless their position in the electrochemical series. So, when the platinum cathode is used, hydrogen proton is discharged. I think this is the same as in electrochemical series, but you have to see this is different to the result you obtained when mercury cathode was used. As when mercury cathode was used, sodium ion was electrolyzed. So the nature of electrode can decide which kind of ion to be electrolyzed, regardless other remaining two factors. Now, here, when platinum cathode is used, hydrogen proton is going to be discharged. So hydrogen proton will be discharged. At the cathode to liberate hydrogen gas. Now this is the way it occurs. So you have to put in your mind that sometimes the nature of electrode can decide which product will be obtained after electrolysis. And when you use different electrodes, you can find that you get different products. So you have to keep in mind the three factors which determine the preferential discharge of ions during electrolysis. We have the first factor is the position of an ion in an electrochemical series, I mean easy discharge of ions. The second factor, concentration of ions, and a third factor is the nature of electrodes. Thank you for attending today's session. I hope you have understood well. I take this chance to welcome you in the next sessions. Have a nice moment. I say bye.